Hello. Okay, now that we have talked about central angles and arc measures, we are going to talk about arc length. And arc length is different than the measure of an arc. The measure of an arc is always in degrees. So I'm going to put that just a little note up here. The measure is always degrees. The length of an arc is always it always has units, like its length. So you're going to see it in meters or feet or millimeters, centimeters, all of those things will help you find arc length. Now, the arc length formula is on your dictionary page, and it is L equals x over 360 times c. And x is the degree of the measure of the arc, and again, that's degrees, and c is your circumference. And in case you needed to remember, c is 2 pi r. Now, I'm not going to be doing all of the problems on this page, or maybe I will, I don't know. We'll just see how this goes. Okay, so our first question says that EB, so EB is this radius right here, and it's 15 centimeters. And we need to know the length of arc CD. So we're wanting to know how long that piece of the circle is. Well, your first piece of information should be what's the measure of the central angle, because we need to know the degree of the measure of the arc in order to find our measure of to find the length of our arc. To do that, we're going to do 180 minus 68, which is going to give us 112 degrees. So we're going to take 112 out of 360, and then we're going to multiply it by our circumference, which again is 2 pi r. So 2, and I'm going to put my radius here, 2 times 15 times pi. Now, for all intents and purposes, the only part we're going to put into our calculator is this. So 112 out of 360 times 2 times 15. And with any luck, Desmos is still pulled up. So we're going to do 112 divided by 360 times 2 times 15. Now notice this gives us to us in a decimal. So I'm going to hit that fraction key right next to the number, and I get 28 over 3. So my final answer is 28 over 3. And then we throw our pi on the end so that this is the length of our arc. Now, number 11, they give us that NR is 8, so our radius is 8, and we need to find the length of N to M to P. And so if MQ is 162, then that means that this arc right here is 18, and so this arc right here is also 18. So that means that our arc measure is 198 degrees, because we have 180, that's our semicircle, plus this extra right here, which is 18. So 180 plus 18. Then we're going to do 198 out of 360 times 2 times our radius times pi. And again, this part is going into the calculator. So 198 divided by 360 times 2 times our radius. And again, we've got that in a decimal, so this is going to be 44 over 5 pi. So 44 over 5 pi is our final answer. Okay, question 12. If VS, now here's the tricky part, because VS is actually a diameter. So that means that our radius is going to be 6 in this case. And we need to know the arc length of arc UT. Now, to get UT, we're going to have to do a couple of different things here. This is 180 here. And so we need to find this piece. So we're going to do 180 minus 127, which is going to give us 53. And then if you'll notice, our little right angle right here makes this a right angle. So 90 minus 53 is going to be 37 degrees. So our arc measure is 37 degrees. And again, just like with the central angles, if you can put all of the measures of all of your arcs in, then you'll pretty quickly be able to identify what you need to identify. So we're going to do 37 out of 360, which is ridiculously ugly, but we're going to go with it, times 2 times 6 pi. So we go back to Desmos. 37 out of 360 times 2 times 6. And for this one, we're going to get 37 over 30 pi. So our part in Desmos was this. That gives us 37 over 30. Pi hangs out there on the end, and there's our final answer. So 13. JH, in this case, is 21. So our radius is going to be 10.5. We want to know the length of our arc that goes from K through J and ends at G. K through J through G. Now, if I look at this diameter and this diameter, we can see that this central angle is going to be equal to this angle. And what we're basically going to do is we are including everything except that little tiny green sector. So I'm going to do 85 minus 59. And when I do that, I get 26 degrees as the measure for that green angle. And so to get the measure of my purple arc, I've got to do 360 minus 26. And to get that, I'm going to get 334 degrees. So we are going to do 334 degrees out of 360 times 2 times 10.5, and then we throw our pi on the end. Okay, so notice that was just one little step at a time. That's all you got to do. So 334 out of 360 times 2 times 10.5. And this is going to be something pretty ugly, you guys. 1169 over 60. And we're just going to leave it like that. 1169 over 60. Throw our pi on the end. And there is our answer. For 14, FG, so this is just our radius, is 27. And we need to know the measure of F to E to D. Now, notice they didn't give us a very nice little, we don't have a diameter here. So all I'm going to do, they gave us the measure of this arc and this arc. So I'm going to take both of those and subtract them from 360. So 360 minus 47 minus 80. And guess what? I'm not going to do this in my head. 360 minus 47 minus 80 is 233. So my arc measure is 233 degrees. So I'm going to have 233 out of 360 times 2 times 27 times pi. And again, we're going to go back to Desmos. 233 out of 360 times 2 times 27. And this is going to be 699 out of 20. So green part that went into Desmos is 699 out of 20. Throw our pi on the end, and there is our final answer. We're not going to do 15 because I think that you've seen enough, but I hope that this will help you find arc length. And next we're going on to sector area.